Hey guys, so today this video is going to contain 8.5, which is writing trig functions going backwards, so having the graphs, and also 8.6, graphing tangents. So depending on how I separated your packet, you might only have to do the first half. Otherwise, you'll have to do both. So keep in mind with what packet you have. Okay, so one thing I want to mention right now, just so we are on set one, is we are not doing a phase shift. So no matter what, we're going to start at the y-axis, okay? So that helps us identify whether our graph is going to be sine or cosine. Let's keep in mind our sine and cosine graphs. Think of this. Sine, you remember, started at 0, went to 1, went to 0, went to -1, went to 0. So as you can see right here, your sine graph started at the midline, where your cosine started at 1, went to 0, went to -1, went to 0, went back to 1. Okay. Now I also want you guys to keep in mind that if our sine were negative, it would still start in the midline, but it would go down instead of up. Go down instead of up. Cosine, of course, would not start up, it would start down and make a hill. Okay, so let's keep that in mind when we're looking at these examples going backwards. Because that's where I start. I ask myself, what equation am I making? Now, some of you in your practice work, it might tell you in the directions what exactly it wants you to make. Okay, so keep that in mind. Some of you, it's going to be mixed up and you got to figure that out. So if we look right here, I'm starting at 2. Remember, because I'm starting at the y-axis. So if I look, this 2 here is in the middle. So which one of these starts in the middle? That would be sine. Now, what I want to also point out is that what happens? It goes down first, not up. So that means it must be a negative sign. All right. Before we get to amplitude, because amplitude's that distance between the midline and the max, or the mid, we should probably find the midline. So it's kind of weird that I made these notes up and had the midline here. So we're going to go here next. The midline, remember, is that middle of your graph. So I like drawing a line there to show that middle and to analyze, hey, visually, is it the same distance here to here? And it is. So the midline is at 2, a positive 2, right? And then the amplitude is that distance from the midline to the top. 1, 2, 3. Let me double check from the mid. 1, 2, 3. So it is 3. All right, now here is the tricky part, okay? So you got to do this math. Remember, for sine and cosine, our period is 2 pi over b, right? So I'm going to put this 2 pi over b. Now, also we can conclude that our period, remember, is where it starts repeating. So if I look at the midline and going down, remember, I cross over, so look at my sine. I go midline, midline, midline. So it's my third midline. So 1, there's my second. That means this is my third. Okay, so as you can see, this graph actually has 2 periods in it. But when we're talking about the period, we want to talk about 1 period. So do you guys see that the 1 period is at 2 pi? So that means that 2 pi equals 2 pi over b equals that 2 pi. And now what we're going to do, because we don't need the period in the function, we need the b value. We're going to solve for b. So I get 2 pi equals, because I'm going to multiply both sides by b. Then I'm going to get b by itself by dividing by 2 pi. And of course, 2 pi over 2 pi is 1. All right, so how do we set this up for the equation? If you need a reminder, go back to your 8.4 notes. Okay, we always start, now it's a negative, so negative is always up front. My next value is my amplitude. Then it's my trig function. Then we go, remember, it's the period times x. So I'm just going to write 1x, even though you do not have to write the 1. And then at the very end, what do we write down? We write down our vertical shift, which is a positive 2. And we just made our trig function. Okay, let's try this one more time. Okay, where are we starting? I'm starting at -3 here. And it looks like, according to my whole graph, it is the top, the max value, which means we are doing cosine. And since it starts at the top, it is a positive cosine. If it were at the bottom, it would be negative. Let's look at the midline. Let's look at halfway in between. Looks like that's halfway in, right? So that's at -4. Okay, how far up? How far down? Well, it looks like 1. Now, also be careful about your units, guys, because if these units change, it might not be by 1. Yes, it's 1 square, but each square could be 2. You never know. Okay, so be careful. Now, let's talk about our period. I'm going to first set this up as 2 pi over b. And then remember, for a whole period for cosine, if I start up, my period ends up. So I'm going to trace that. Get my red. So I'm going to wait until I get up again. I get up at, it looks like pi. Okay, so let's set this equal to pi, and then we're going to solve. I'm going to solve just like I did up here. I'm going to multiply both sides by b. And then I'm going to divide by pi to get b by itself. And what happens on that left side? Well, the pi's would cancel, so we get 2 equals b. Okay, let's write our function. We start with our amplitude. I'm going to write it in, but you don't have to because of 1, right? I'm just going to write it so you know where it goes. That's the amplitude. Then we have our function. Then remember, it's our b value times x. And at the very end, we have a -4. And we're done. So be careful of your places. You can look at your 8.4 notes to make sure this is A, B, and your midline, right? Your C, your D. Okay, but remember that your B has to deal with the period, but it's not the exact period. Okay, and that's all for writing trig functions. Now I'm going to go on to graphing tangent. Okay. Now, what's great about graphing tangent is that if you think of your unit circle, you realize that you start repeating itself every pi, right? At 0, it's 0. At pi over 2, it's undefined. Remember the y over x. Remember, we learned from 8.3 that tangent of theta equals y over x. You can look at your unit circle and say, hey, at theta equals 0, our tangent is 0. Theta equals pi over 2. Well, that would be 1 over 0, which is undefined. Pi is back to 0. And 3 pi over 2 is undefined. So see how it starts repeating itself at pi instead of 2 pi like our cosine and sine? That's because our period now, to find our period, is pi over b. It's not 2 pi over b. So that's going to be our tricky part, okay? So let's set up what our table would look like for our transformations. Well, instead of going just the 3 points, because remember for cosine and sine, we used 5 points, right? But I'm only going from 0 to pi, so I know exactly what's going on. So let's break this up into 0, pi fourths, pi halves, 3 pi fourths, and pi. Okay, now I already went through that at theta equals 0, we get 0. At pi over 2, we got undefined. And at, actually guys, I'm going to back up a little bit. I like this idea, but look, if I start at 0 and go to pi, I have this weird indication, and you can't really see what's going on with the graph. So my period is still going to be the value of pi, but what I'm actually going to go for is asymptotes to asymptotes. So sorry for erasing, but I want you to get the full effect of what tangent looks like. So I want you to use this part of the table. We're actually going to go from negative pi over 2, negative pi fourths, 0 pi fourths, pi over 2. Now, even though this is pi over 2, negative pi over 2 to pi over 2 is a full pi, okay? This is better because now we get that full curve that you see in this parent function right here. So at negative pi over 2, well, our pi's over 2 are undefined. So our pi over 4s, well, let's think of it. Look at your unit circle right now. When we look at our unit circle and we go pi over 4, we get the square root of 2 over 2, comma, square root of 2 over 2. Tangent is y over x. Well, what is anything over itself? It is a value of 1. At 0, we pointed out before it's 0. Well, pi over 4, it's still 1, right? Pi over 2, it is undefined. Now, I want to point something out before we go further because I made a mistake here. Did anyone figure that out? Because negative pi over 4 is down here, right? On our unit circle. So really the coordinate we're looking at is square root of 2 over 2, comma, negative square root of 2 over 2. What is a negative over a positive? It is a negative. Okay. So this is the table that we're going to use for our transformations. Everything else is the same. Now, with tangent, though, we have asymptotes. That's where our undefineds come in. So I want you to label those. And then we're going to label our period and our y-intercept. We really don't have amplitude here because we don't have a max or min height. We don't have a midline either. We just talk about y-asymptote. Technically, your midline would be where all those curves are. Okay, here we go. Let's do some examples. Period. Remember, I told you the period in this case for tangent is going to be pi over b. Our b is still in front of x. So right here we have pi over 1/2. We did a lot of practice with this with sine and cosine. Dividing by a fraction is the same thing as multiplying by its reciprocal. So that means our period is 2 pi. Vertical asymptotes are where, actually, let's talk about vertical asymptotes after we do our table. And then the y-intercept, guys, will always be just like in our regular linear equations. It's always what's added on to the very end, which in this case is 0. Okay, because, okay, if you want, mark this. Y-intercept for your notes. Okay, like I said, before we do the vertical asymptotes, I'm going to make my table. I'm going to make it over here. Sorry, I didn't give you much room today. Now remember, we're not using our sine stuff or our cosine stuff. We're using our tangents. So if we look and we copy the table above, we go negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. Okay, that was undefined. We have negative 1, 0, 1, undefined. I'm going to run into my graph, aren't I? Let's see. On the outside here, we have nothing on the outside, right? So we're not actually doing anything to the y values. On the inside, though, our b is 1/2. Remember, we do the opposite, so we're going to multiply by 2. So if I multiply all these x values by 2, we get negative pi halves, 0, pi halves, and pi. Our period was 2 pi. Well, negative pi to 0 is pi, and 0 to pi is pi, 2 pi. So we're good. Let's go back to our vertical asymptotes. Our vertical asymptotes is where it says it's undefined. So our vertical asymptotes are at negative pi and pi. I'm okay with you guys just putting these sets of asymptotes. I know we're going to have more asymptotes because it repeats itself always, like sine and cosine. But we're going to go into that deeper when you go into 1060, okay? So let me do my x and y axis. Now, usually what I like doing, guys, is I'll put it right in the middle. And I'll draw in my asymptotes. Now make sure they're evenly spaced. I'm just going to go 3 out because I can. No, never mind. I want to go 4 out because I have to have the negative pi over 2. So I'm going to make this asymptote right here negative pi. And I'm going to make 4 out this asymptote pi. Now I know I'm going to have a point at negative pi halves and one at pi halves. All right, ready to graph, guys? So at negative pi over 2, we have negative 1. Let's see, let's do 2 again, at 1 and negative 1. So right here, I have 0, 0. And we have pi over 2, 1. Now I know this is going to look linear, but it's not. If you go back to the parent function, it's that curve. And when we curve, we always get close to those asymptotes. And we're done. Now, of course, this graph will keep repeating. Okay, we have a bunch of asymptotes. All right, one more, and then I'll have you guys practice on your own. Let's do the period. Remember, this is tangent, so it's going to be pi over b, which in this case is pi over pi. I said b again. And of course, anything over itself is the value of 1. Let's wait with our vertical asymptotes. y-intercept is always what's added on the end. So this is 0, 2, or we can think of it as going up 2. Now I want to remind myself there's a negative out front, so we're going to flip it. It should be flipped. Let's make our parent function table. Negative pi over 2, negative pi over 4, 0, pi over 4, pi over 2. So we have undefined. We have negative 1, 0, 1, undefined. All right, I don't know about you, but I like doing my y stuff better. So I have a negative to keep in mind and a plus 2. Remember, we go left to right. So I'm going to multiply by negative 1 first. So undefined stays undefined. Negative 1 times negative 1 is 1, 0, negative 1, undefined, running out of room. And then I have this plus 2. Undefined plus 2 is still undefined. 1 plus 2 is 3. 0 plus 2 is 2. Negative 1 plus 2 is 1. And undefined stays. Okay, let's do our period. So this is multiplying by pi. So what we're actually going to do is multiply by 1 over pi. What does that do for us in all of our x values? Well, in this case, because we're dividing by pi, all of our pi's cancel, right? So I left with negative 1/2, negative 1/4, 0, 1/4, and 1/2. Does that make sense according to our period? Yeah, because this is 1 and this is a half and this is a half, which makes a whole. So that means our asymptotes right now are at negative 1/2 and a half. Again, we'll make equations for those when we get into 1060. If you ever get there, that is. Or if you want to, I should say. Okay, let's mark this. Now, what's really big is what you found with sine and cosine, other than phase shift, is that our graph kind of looked the same the whole time. And that's because you were making your own units. So that's why you want to label everything. Because you'll find that I'm going to make this look the same. So I'm going to put this asymptote down here. But of course, this asymptote is no longer at negative pi. It is at negative 1/2. So you can make your asymptotes wherever, as long as they're evenly spaced and they're labeled. And this one is 1/2. Which means right in the middle is our negative 1/4 and our 1/4. All right, let's graph these. So at negative 1/4, we're at 3. So I'm actually going to just do every one now, not every other one, just in case. So at negative 1/4, I'm at 3. At 0, I'm at 2, and that makes sense, right? Because our y-intercept's at 0, 2. And our 1/4 is at 1. Almost second guess myself there. Again, not linear, right? It's that curve. So lots of times, guys, to make this easier, I start from that y-intercept there, and I curve. And you have to get close to the asymptote. Now this one flipped. Were we supposed to flip? Flipped. Were we supposed to flip? Yeah, we flip right there. Very good. Okay, now do some practice on your own.